All right, this is the first part of the geometric series notes. A geometric series, just like we did arithmetic series, is just the sum of a geometric sequence. Okay. To find this sum, and also we're going to be doing two different types of sums today. We'll be doing a finite sum, which means it has a distinct number of terms, and then we'll also be doing an infinite sum. But for a finite sum, it is S sub n equals a1 parentheses 1 minus r to the n over 1 minus r, where n is the number of terms, a1 is your first term, and r is the common ratio. So we're going to go through these first few here, and we'll look through the indicated sum that they give us. The first one that they have here for us is S9. So in our formula, we need to plug in an a sub 1, we need to plug in an r, we need to plug in an n. So once you have those three, then you're good to go. So a sub 1, we can easily see is just 2. So we've got a sub 1 is 2. And then to find r, second term divided by first term, so that's going to give me with 5, and n will be 9. And you basically plug them in, so use your calculators. This would definitely be on the calculator section. So you want s sub 9 equals 2 times 1 minus 5 to the 9th over 1 minus 5. And you just have to be careful when you do this 1 minus 5 to the 9th. I would keep it like a positive 5 to the 9th, and then just do 1 minus that answer. So let me just show you what you would get for that. So S9 would be 2 times, for 5 to the 9th, it is 195, 3125, and then over negative 4. And then just continue to put that in the calculator and work it all the way out. You're going to get 976,562. So for summing the first 9 terms, you get a very large number. Go ahead and try the second one. So this time we're finding S sub 8. So again, your A1 is 72. You know your R is negative 36 divided by 72, which is negative 1/2, and your N is 8. Again, plugging it all in, and just again, when you plug it in, make sure that you are being careful with your calculator options. So we have S8 equals first term, so 72 times, what's going on? There it goes, 72 times 1 minus a negative 1/2 to the 8th over 1 minus a negative 1/2. Now, here you do have to be very careful. You are not allowed to make these turn into positive. You must work on the negative to the 8th power first. So do that math first. That's going to change to positive. Here you can chop because there's no power, so that'll just be 3 over 2. So again, just be careful in the calculator. So you'll be doing 1 minus whatever a 1/2 to the 8th power is. And as you go through and compute that, you should get s to the 8 equals 47.8125. So this one did not get very big. All right, let's try the next one. So for these ones, you're going to notice you don't actually have an n. Like, it just gives you the sequence and it says ... So for this one, we do need to find what the n is. So we are going to go and write an a sub n rule. So from before, let's go ahead and still get our data though. So you have a1 is negative 4. You have your r is negative 8 divided by negative 4, or 2. And we're going to try to find n. So we'll find n by working out the a sub n formula. So we're going to do a sub n. So a sub n equals a1, so negative 4, and then r2 to the n minus 1. Remember, for a sub n, the rule is n minus 1. We know the a sub n we want, though. We want this negative 16,000. That's the number. We just need to figure out what n position that's in. So you're going to put that over here. So negative 16,384 equals negative 4, parentheses 2 to the n minus 1. And now you can divide both sides by negative 4. So that's going to give you 4,096. So 4096, let's cancel, equals 2 to the n minus 1. And then there's a couple different ways to approach this. You're supposed to approach it with logs, but you could also just set up a proportion to try to figure out what this would be. Well, you know, if you can figure out in your calculator, this would be 2 to the 12th. So this would be 2 to the 12th equals 2 to the n minus 1. Well, then you can just set the powers equal to each other. So you can just go ahead and say that this 12 is equal to this n minus 1 and make an equation using that. And that's what we're going to do. The next one we'll do logs. So I'll remind you how to do logs on this. So you do 12 equals n minus 1. So if you add 1 to both sides, you get n is 13. And now you do have to still plug everything into your S formula to figure out the sum of the first 13 terms. Let's squeeze that in. So you'll do S13 equals your first term, 1 minus r. So 2 to the 13 over 1 minus 2. Not a lot of room, so just put it on your calculator, make sure it comes out right. Negative 32,764. That's what I'm getting for that. Now we're going to try another one that's very similar. Again, we don't know the n, but we're going to use logs to figure it out. Boy, there's not a lot of space here. Let's see. Yeah, we'll write small. So I'm going to go straight to our a sub n rule. So a sub n, just because we need the space. So a1, so 2,500 times r, which is 0.8. So again, r is 2,000 divided by 2,500. So 2,000 divided by 2,500 just gives me 0.8. And then I'm taking that to the n minus 1. But don't forget, use that. That's the number in the a sub n position that you're looking for. So plug in the 655.36 equals 2,500, 0.8 to the n minus 1. We are going to divide both sides by 2,500. It's not going to be nice. So I'm going to keep as many decimals as I can. So 0.262144 equals 0.8 n minus 1. And now what you're really supposed to do is use logarithms. So when you base something with a log, then that makes the power drop down, so it's no longer in an exponent. So you're supposed to take this log of 0.8 and do log of 0.8 to both sides, like that, from algebra 2. That means this piece right here would cancel, and you get n minus 1. But if you don't have that log button on your calculator that lets you use a different base, because we need a 0.8 base, I'm going to go ahead and write this in change of base form here. So remember, the base goes on the bottom, so it's going to be a log 0.8 on the bottom, and then a log of that 0.26 number. So log 0.262144. That's going to equal n minus 1. You will put all that, oh, sorry about the focus. You're going to put all that in the calculator, and luckily, this whole thing just ends up giving you a 6. So 6 equals n minus 1. Make sure you put log of this, hold on to that long decimal, and divide it by log of 0.8. So don't shorten it. Use the entire decimal in your calculator. So if you add 1, you get n is 7. So now we can go ahead and find S7. So for S7, so your first term, 2,500 times 1 minus r, which was 0.8 to the 7, over 1 minus 0.8, sorry, it's a little tight in the room here. You're going to end up getting 9,878.56. And again, you can go ahead and try to redo example 3 over here using log base. The same answer will give it to you. We just did it slightly different because the numbers weren't decimals. Now we're going to switch to our sigma notation here. So when you're doing sigma notation, remember, you have everything you need. You know these are both geometric because they have powers. So if they were arithmetic, they would not have these exponents sitting in the, or these variables in the powers. They wouldn't be there. They'd be a linear term. So remember, this is your starting, this is your stopping. So we're going to need an A1. And this is generally in the form of your geometric. So your geometric rule is a sub 1r to the n minus 1. This is very much set up like that. Just be careful in case it doesn't start at 1. And if it's not an n minus 1, in case it's an n, because then things go a little weird. But anyways, let's go ahead. So our A1 is 3. Our r is negative 4. And again, you're just looking at placement. And then our n is your upper limit on your sigma, so 7. So you're going to plug in s of 7. S7 equals, you want your first term, so 3 times 1 minus, be careful, our r is negative. So whenever your r is negative, make sure you're putting those double parentheses on there. So, oh, the focus left again. There it goes. So this negative, don't chop yet. Do this one first. That will end up giving you a negative, and then you can add it, okay? So then this one will chop and make it a 5. So again, just so you can see some of the math, this will end up being 1 minus a negative 16,384 over a 5, like that. And then if you go ahead and compute that, it's going to be 9,831. 9831. It's a 3. So again, if we do another sigma, you can write your a sub n rule right underneath and just kind of compare the two. So for this one, your a1 r to the n minus 1, so a1 looks like negative 5, r is 2, our n is 18. So this one going up so high is going to be a decently big number because we're going to the 18th sum. So then you plug everything in. So you're going to do s of 18 equals your first term, so negative 5, 1 minus negative 2 to the 18, sorry, positive 2, over 1 minus 2. So it's just a 1 minus 2. I added in a extra accidentally. And then you do all the math on that, and you should get negative 1,310,715.